Hello and welcome to GW Prime Live. I'm your host Vaishali Dixit, and today we have with us a very special guest who is a geospatial expert, a leader, powerhouse of courage, and above all, an amazing human being. Our very own Nadine Alame, Executive Director at Taylor Geospatial Institute. Welcome, Nadine, and good morning. So happy to have you here today.
Thank you so much, Vaishali, and back at you as amazing woman and leader. And congratulations again on this amazing milestone for GW. Congratulations to you and the entire team.
Thank you, Nadine. Before we kickstart the technology conversation, I have to say you inspire me, so many of us, with an amazing work you are doing and truly leading by example. You once mentioned geospatial science has expanded into more markets that can fit on a piece of paper, and also said time for geospatial is now, which is 100% correct. Geospatial has evolved technologically by using the best available from computers to expert systems, IoT, big data, and AI. A higher level convergence is seen with business intelligence, BIM, ERP, and digital twin. We would like to hear your views on the role of geospatial in making the world more sustainable and resilient.
Yes, how much time do you have? I think you captured it right, Vashali. This is the time for geospatial, and I've been saying this is the time for geospatial year after year after year for like the 20 past years, because like you said, there's always some new advancements either in technologies or in data collection or in how we're putting the data together and we're integrating it in all the markets that you said don't fit on a piece of paper. So how we're changing things is, I think, finally we're at this point where things are coming together. People often refer to the iPhone as an example, where the pieces inside of the iPhone have been around for a while, but the iPhone was a moment where all these pieces that are inside your phone all of a sudden made this big leap in technology that's now in all of our hands. And I think this is what geospatial is right now, because you've got the data and you've got the AI, which we'll talk more about the AI. And we also, over the last few years, have made some progress, actually very good progress, in lowering the bar a little bit for the people, not just the software engineers and developers, to actually use all of that. So that's why I think we're seeing this proliferation right now in geospatial in markets. Now, for sustainability, for climate, for resilience, it's all eventually because we've got the data now about the Earth from the likes of Planet, for the likes of Satellogic, like every day. So as the executive director of a research institute, there's no better time, because now it's at your fingertips and you got the brains who can now use all of that to help you. When we say, Esri has been saying it for years, look at the future, right? Mm-hmm. So hope this gives a little glimpse. Data, information is what makes us make decisions and policies for resilience and sustainability.
Yeah, indeed. As you said, in the very first statement, we cannot complete the sentence without using the word AI. AI is here, there, and everywhere. The impact of artificial intelligence on business is profound, as it is transforming the way companies operate and creating new opportunities for growth. TGI has also created a working group on GeoAI. On that note, can you throw some light on the impact of AI on geospatial and what can be done to build a comprehensive geospatial ecosystem?
So this interview is so timely because literally I was, it's 9 a.m. here in Washington, D.C., so I'm just like browsing the news before I look at my emails. And I see this article, I think it's today, by Emiliano, the CEO of Satellogic. And what does it say? The future of Earth observation lies inside visual language AI models. And the reason I'm like, what? It says the Chat GPT moment for Earth observation is coming. And I think this is my answer. This is the key to this AI and geospatial. And you mentioned the GeoAI working group by the Taylor Geospatial Institute, where we had Josh Delmonico, the executive director of the the Federal Geographic Data Committee here in the US. And he said the vision is eventually exactly what Emiliano's saying, a chat GPT interface, right? The people who say AI is the new UI. So you don't have all the analysts working or even software developers. You just ask questions, right? And I think this is the future of geospatial, that we have enough data, enough training, and enough power for the AI, because that needs a lot of power, so that you can say, where should I deploy my first responders? How many should I deploy and where? How is the disease spreading? When should I close a dam for a flooding event? Where should I, send my resources like health? It applies in the military for soldiers, but this is huge. That I think this is the power of AI and geospatial, that we were doing what the best we can, right? Doing the analysis, and now you can do it at such scale at even Earth level, right? And that links back to your first question. That's how we see the window into the sustainability and resilience, because we got the data, we got the models, and then we can get the information.
Right. Yeah. So we are really looking forward to see how great work the group, GOAI group under TGI will do. And so I'm looking forward to have some fresh news coming out of it. So moving forward, TGI's mission is to catalyze collaboration across researchers, connecting with industry and government partners, and fueling innovation and solutions. In view of this pertinent mission, what are the key focus area of Taylor Geospatial Institute?
So it's very exciting to me to work with the TGI consortium researchers, because the diversity of the research in geospatial was actually, even more amazing than I imagined. And so to group all that expertise, we picked what we call the core geospatial science. So which includes even I would call the basic research on geodesy, or, PNT, position navigation and timing. So you got that. And then in terms of domains, we have food security and digital agriculture, because the Taylor Geospatial Institute essentially is based in the Midwest, in St. Louis, in the Midwest of the US, where they have the largest agricultural land, essentially. So bubbling food security as a theme. From food security, under it, there's actually water security, there's climate impact, and then you have health and national security. But also, if you think about it, they're really not like vertical domains. I think they all intertwine, because you cannot, have national security without food security. Everything is really climate impact, including health and water. And so it's like four, but actually they blend into each other a lot, which is honestly, this is geospatial, right? You cannot say this box right here.
Of course, yes. And the world is full of diversities in terms of people, culture, policies, as well as the industries. So, what are the challenges that are out there that geospatial adoption is making? What are the challenges for geospatial adoption in different levels, at different levels for different industries, if you talk about?
Yeah, I'll give you a very simple example. I was at an event at the University of Missouri, St. Louis on Monday. right? And they were showing what some of the researchers are doing. And one of the applications was flooding, right? Flash flooding in that case in St. Louis. And it was amazing. You use SAR and you use planet data, and you use actual sensors on the streets, water gauges, and all of that. It was great. And then somebody from the audience who's not a geospatial person, but actually is more of a policy person, she came up to me and she said, how can we introduce this to the mayor and to the governor, right? How can we use this so that we can actually create the impact that we're all talking about?
Yeah.
And I was like, oh my God, this is painful to hear, right? When you talk about the adoption level, because we're doing amazing stuff. So, but it's still not making its way to policy without us lobbying for it, right? You, me, everybody in the the GW, the geospatial world, right? So I think we have that problem yet, that we haven't made what we do as part of the policy process, the government decision process. Not that when they remember or when they know somebody, but it's actually part of information gathering, right, to make a policy decision. So I think that's one challenge. And we keep talking about remember when we had the GeoGov session, like planning workshop a few months ago, same thing. It was like, how can we brand this better? How can we better articulate those use cases in language that the decision makers can actually understand? So I see this as one of the toughest adoption challenges. You have others actually where at the lower level it's still hard technically, right? That's why earlier I was like, we've made a little progress, but actually so I'll give you an example. TGI is working with St. Louis University to recruit 20 faculty across various departments. So you know how hard it is actually to say get a biology professor or an aviation faculty that also not just understands geospatial, but actually can use our tools and knows our data formats and can follow metadata, right? It's just like this, and these are super qualified people. That's a challenge as well, that geospatial is integrated in every domain, but also not quite as integrated as it could be. And I think we can talk for hours about the talent and the reskilling, and I'm having trouble recruiting. I hear everybody's having trouble recruiting. So I don't want to spend the whole time talking about the tough problems, but we have some challenges, like you said. Yeah.
I believe together we have to make this happen. Knowledge awareness for policy advocacy. These things has to keep on going. It's a continuous process. So yeah. And on that, there's a very beautiful case study on the Arctic tundra, which is really fascinating. And I have gone through it on the TGI website, and I would like you to throw some more light on the key pointers of that case study for me and for our audience.
Oh, so first of all, thank you for checking our website because we're trying to connect with all the researchers. We have about 200 plus researchers across the 8 institutions that make up the Taylor Geospatial Institute. And you learn something new every day, actually multiple times a day. And this is one. And I think as a background, one of the themes actually is carbon, right? It comes up a lot, right? Because of, climate, resilience, adaptability, ESG, you name it. So in this case, in the Arctic, and this is one of the projects in the Arctic, again, when we talk national security, the Arctic spatial data infrastructure is a key part of this. And I was learning about this, that there's this thing called the permafrost. This is not my domain, but this is exciting, right? So
Yeah.
this is sort of like frozen soil, right, in the Arctic, but it stores a lot of carbon in it. And now with global warming and the melting or the thawing, that carbon is being released. So this study was a study using INSAR in this case. So INSAR, I think, and they used hyperspectral to find these permafrost, and sort of we want to try to estimate how much carbon there is in that soil and how much carbon is released and what you can do about that. So that's fascinating. What's even more fascinating to me is when you couple that, so you've got these researchers working on the carbon permafrost, so frozen soil in the Arctic. So these researchers are from Urbana-Champaign. Our friends are Urbana-Champaign. And then you have other friends who are working, for example, on carbon from trees, and in this case, they were working with NASA to count all the trees, count and monitor all the trees in Africa, for example, using NASA's data so that you can derive carbon information. And then you have these folks from, I think, University of Missouri, and what these guys, Columbia, and these guys were doing in that case through drones and LiDAR information. So you get a little bit, you zoom in, right? So space, whatever, and based on the tree heights, and then you've got these drones that are picking up soil samples, and it's all the where I'm going is just collecting carbon information from all these sources so that we can truly estimate. You go where we started, the Earth, the globe, climate resilience, and all of that. So this case study is fascinating. And what's even more fascinating is when we try to put these pieces together, these individual research projects together, so that you can truly understand the Earth, right?
Yeah. Yeah. I think it's a perfect example of interdisciplinary and organizational collaboration for the benefit of the Earth via geospatial technologies, if we talk about it. So as we are coming to close of the session, I would very quickly would like to know from you, as a seasonal, geospatial industry professional, Nadine, what is the one thing which the industry should focus on urgently?
Can I say one thing? All right.
Few things.
On a domain, I think from a domain perspective, I'll repeat what everybody's saying, which is let's put our heads together, and those individual research and innovation and applications and players to understand the Earth, to understand climate, so that we can all plan for our common future on this Earth. So from a domain perspective, climate pulls everything together. It's definitely urgent. So that's definitely the one thing. But to make that happen, and I think this is going back to my roots at the Open Geospatial Consortium, for example, we're not going to make that happen if we don't work together. So we're going to say it's not just collaboration because we love each other. I mean collaboration with openness. When we're talking earlier about the artificial intelligence models, how about open foundation geospatial models for everybody? So this open data, open science, I think it's also very related to the climate and the Earth understanding. And the last urgent thing is the people, the talent. How do I get my kids interested and their friends so that they can use this in every domain that they're in? And we need that urgently, because we can't keep spending our energies promoting this. We have work to do. There's a lot of work that needs to be done for the climate, for the openness, for the collaboration, for research. So climate, open science, and investment in people training and reskilling. Three urgent things.
No, you can add few more points as they are. I'm talking about the most urgent need for geospatial to penetrate into the markets. And as I realize, we have some time, so it's going really great. And you saying something, it's always good to listen to.
Thank you very much.
You can add few more points as you feel like.
I think you hit on it earlier. Interdisciplinary, inter-organization at scale. So I would add, because we started with the AI, it's transforming not just geospatial, but many other things. We need to be at the forefront of this. And if we want to make an impact as a geospatial industry, we need to work together, at least for these geospatial foundation models or Earth observation. We have the power, right, to understand data, like I said, from space and from drones and from robots. And then you couple that with video data. So I'm going with multimodal, fusion and, geospatial models. And again, if you want to achieve the vision, it's urgent, right? Going back to the urgency theme, it's urgent for us to set up the right infrastructure, right, for the future. This is what we're doing right now. We're setting the infrastructure for the future. And since I have a couple more minutes, I wouldn't be me if I didn't say it's urgent to remind people that we have ethical responsibilities here. It keeps coming up, the ethical, responsible use of this power that we have as a community, as an industry, the bias in AI, all of this, it needs to be also at the forefront. So that's how I'll use my 2 minutes. Again, another shout out for the Locust Charter from our friends at Ethical Geo, because it's an important part of our future as well.
Yeah, technology is there and it will keep on evolving. It's up to us how beautifully and how interestingly we use it for making the world and the earth better to live in. With this, we come to an end of this session. Thank you so much, Nadine, for taking out time and joining with us at the start of your day. Hope you have a beautiful day. And I look forward to seeing you on May 13th at Rotterdam.
Absolutely. Thank you for having me.
Thank you. Bye.
Thank you. Bye. Have a good day.
Maps are generally geographical, geopolitical, or geological representations of the Earth's surface in a simple, visual way. A map contains different layers of data, with geographic information that serves as a background, called a base map. Let us understand, what is a base map? A base map provides context for additional layers, overlaid on top of the reference map. It usually provides location references, for features like boundaries, rivers, lakes, roads, and highways. Base maps are essential for all types of mapping. Even dynamic interactive maps required base maps, for quick references and human understanding. Here are some examples of interactive web-based maps. Orthophoto. Orthophoto base maps are orthorectified sums of images. They are usually created by satellite imagery, but can also be created with aerial or drone photography. Topographic. Topographic maps usually show a geographic reference, and a coordinate grid, so you can determine relative and absolute positions of mapped features. Satellite. A satellite base map is a backdrop aerial image in pixels, taken by a satellite orbiting around the area of interest. This is useful to observe quick changes in the natural features of Earth. Elevation. A digital elevation model, also known as a DEM, represents the bare ground topographic surface of the Earth, excluding trees, buildings, and other surface objects. Contours. Elevation contours are another way of showing how elevation changes in geographic locations. These lines show constant heights of elevation. Lines closer together represent steeper terrain.
Hello, everyone, and welcome to GW Prime Live. This is Sachin Awana, your host for today's Case Study Explainer episode. This case study captures how Wales Coastal Monitoring Centre is leveraging photogrammetry for enhanced flood and erosion risk management in Wales. Funded by the Welsh Government, WCMC undertakes annual baseline surveys across the Welsh coastline using drones and Pix4D software. These surveys aim to monitor erosion and assess flood risk and inform coastal management decisions in the face of rising sea levels due to climate change. By leveraging photogrammetry, WCMC conducts topographic profile surveys, captures seawall conditions, and engages in the CoastNAP citizen science project to monitor coastline changes over time. Pix4D Cloud's comparison mode enables trends analysis by comparing datasets and providing valuable insights for national and local level government decision making on flood and coastal erosion risk management strategies. The Wales Coastal Monitoring Centre encounters a range of challenges in its missions, from navigating airspace restrictions and unpredictable weather conditions to ensuring preservation of sensitive habitats during data collection. Moreover, processing extensive datasets and creating standardized reports pose significant computational and organizational obstacles. To overcome these challenges, WCMC employs drones equipped with Pix4D Catch and Pix4D software to conduct comprehensive surveys of the Welsh coastline. This strategic approach enables the generation of high-resolution elevation data, orthomosaics, and 3D models, facilitating precise assessment of erosion, accretion, and coastal asset conditions. By utilizing Pix4D Cloud for data processing and storage, WCMC streamlines operations, saving valuable time and resources while promoting accessibility and collaboration among stakeholders. The insights gleaned from photogrammetric surveys contribute to evidence-based decision making for effective flood and erosion risk management. The adoption of photogrammetry and Pix4D technology yields numerous benefits, including expanded spatial coverage, minimized health and safety risks for surveyors, superior data quality, and standardized report generation. These outputs empower national and local level governments to make informed decisions and implement proactive measures to mitigate the impacts of climate change on coastline areas. Through the deployment of innovative technology solutions, WCMC assumes a pivotal role in safeguarding Wales's coastline and bolstering resilience against future environmental challenges. This commitment ensures the sustainability and safety of coastline communities for generations to come. With this, we reach the end of this episode. See you in the next episode. Thank you for watching.